In today's lecture, I am going to discuss some basic problems given in your exercise of your textbook in page number 99, which are based on the concept which we have already discussed, that is about the operation of matrices, that is addition and multiplication. So first question, you can see the question is given that write in full the 3 by 2 matrix A whose elements are of the form of Aij. That means you have to write a matrix A whose order is 3 by 2. That means I is running from 1 to 2. I denotes the number of row and J denotes the number of column. So as the order of the matrix is 3 by 2, so it will have 3 rows and 2 columns. That means its element will be of the form A11, A12. This is the first row. Second row is A21, A22, and third row is 3132. So this is the first row, second row, third row. 3 rows, 2 columns. So A11, 21, 31. This is the first column. A12, A22, A32. This is the second column. So this is a rectangular matrix of order 3 by 2. Second question is, write in full the 2 by 3 matrix Aij, where Aij is of the satisfy this relation 2i minus j plus 1. That means you have to write a rectangular matrix whose order is 2 by 3. That means it will have 2 rows and 3 columns. So, and the element will be like this: A11, 12, 13. This is the first row. A21, A22, A23. This is the second row. 3 columns. So this is the first column, this is the second column, and this is the third column. So this is the general form of a matrix A whose order is 2 by 3. Now it is given that Aij will satisfy 2i minus j plus 1. That means I will vary from 1 to 2 and 3, and j will vary from 1 to 3. So the first element will be A11. We discussed in the first lecture that the element of a matrix are denoted by its subscript. Two subscript. First subscript denotes its position in the row, and the second subscript denotes the position in column. So this is the first element of first row, first column. So A11. This is the element of first row, second column. So A12. First row, third column. So A13. Second row, first column. So A21. Second row, second column. So 22. Second row, third column. So 23. Now we are going to find out what will be the element A11. When we are finding the value of A11, that means I is 1, J is 1. Okay, so we are getting A11. First row, first column, A11. So put I1 and J1. So we will have this A11 is 2 into 1 minus 1 and plus 1. So plus 1. So it gives A11 is 2. Similarly, the second element, A12. A12, that means I is 1, J is 2. This is the element of first row, second column. So I is 1, J is 2. A12. So put here 2 into I, that is 2 into 1, minus J, J is 2, so minus 2 plus 1. So it gives A12 is 1. Similarly, we can find A13. 13 means I is 1, J is 3. I is 1, J is 3. Put here I is 1, so 2 into 1, J is 3, so minus 3 plus 1. It gives A13 is 0. Similarly, we can find A21. A21 means I is 2, the value of I is 2, J is 1. So 2 into I, that is 2 into 2 minus J is 1, so minus 1 plus 1. So it gives A21 is 4. Similarly, A22, I2, J2. 2 into 2 minus J, so minus 2 plus 1. It gives A22 is 3. Similarly, we can find A23, that is I, put the value of I is 2 and J is 3. So we can find A23 is 2. Now, put all the values of A11, 12, 13 in this matrix and we will get our desired matrix A. That is, the value of A is 2, 1, 0, 4, 3, 2. This is a matrix of order 2 by 3. This is the first row, this is the second row, and this is the first column, second column, and this is the third column. Got it? Next, come to question number 5, and it is given that A is a matrix whose elements are 1, 2, 3, 4, 5, 6. B is another matrix whose element is 2, minus 3, 4, minus 5, 6, 7. These two matrices are of order 2 by 3. This is a matrix of order 2 by 3 and this is again a matrix of order 2 by 3. Now it has been asked that find a matrix C which is equal to 2 into A plus 3 into B. That means you have to first find, you have to write what is the value of 2A. You are already having this matrix A. So 2A means you have to multiply uh, uh, 2 with this matrix A. This is a scalar multiplication. Okay. Similarly, you have a matrix, given matrix B, and you have to find 3B. That means you have to multiply the matrix B with the scalar quantity 3. So find out 2A and 3B. So 2 into A is this matrix. So, by the property of scalar multiplication, each element of the matrix A will get multiplied with 2. So the resultant matrix will be 2 into 1, 2, 2 into 2, 4, 2 into 3, 6. Again 2 into 4, 8, 2 into 5, 10, 2 into 6, 12. Okay, so this is a matrix 2A. Similarly, 3B. This is a matrix B. You have to multiply each element of this matrix with the scalar quantity 3. So 3 into 2, 6. 3 into minus 3, 9, minus 9. 3 into 4, 12. 3 into minus 5, minus 15. 3 into 6, 18. 3 into 7, 21. So this is a matrix 3B. Now you have to add these two matrices, 2A and 3B. So by property of addition, each element of 2A will be added with each element of 3B, corresponding element of 3B, sorry. So A11, suppose this is A11. So A11 will be added with B11. So 2 plus 6, okay. A12 will be added with B12, so 4 plus minus 9. A13 will be added to B13, so 6 plus 12. Similarly, A21 will be added with B21, so 8 plus minus 15, that is 8 minus 15. 10 plus 18, 12 plus 21. So the resultant matrix C will be 2 plus 6, 8, 4 minus 9, minus 5, 6 plus 12, 18, 8 minus 15, that is minus 7, 10 plus 18, that is 28, 12 plus 21, that is 33. In the similar way, we can also find out the value of C, where C is given as 3 minus 4B. You have to here multiply the matrix A with the constant 3, then you will get 3A. Similarly, you have to multiply this matrix B with the scalar quantity 4 and you will get 4B. Then by the property of subtraction, the corresponding element of 3A and 4B will get subtracted with each other. So you can do it by yourself very easily. Now we will discuss the next question, that is question number 7. You are given these two matrices A and B. These two matrices are of the same order. This is square matrix of order 2. This is again a square matrix of order 2. And we have to show that A plus B into A minus B is not equal to A square minus B square. In algebraic formula, we have seen that A plus B into A minus B is always equal to A square minus B square. But this relation doesn't hold in case of matrices. That means we are going to prove this relation, that this relation is not equal. That is A plus B into A minus B is not equal to A square minus B square. So what we will do first, find the value of A plus B. This is a matrix A, this is a matrix of B. By the property of addition of two matrices of same order, A11 will be added with B11. So 1 plus 1 minus 1 plus 0, 0 plus 1 and 2 plus 2. So we are getting A plus B as 2 minus 1, 1, 4. Okay. So A and B are two matrices of same order. So the matrix addition is possible, and matrix addition is possible, and we will add the corresponding element of A and B, and we are having this matrix A plus B. Similar way we can find the value of A minus B by the property of matrix subtraction. The corresponding element will get subtracted, that is 1 will get subtracted from 1, so 1 minus 1, then 0 minus of minus 1, that is second element is minus 1 minus 0, 0 minus 1, 2 minus 2. Okay, so 1 gets subtracted from 1, 0 gets subtracted from minus 1, 1 gets subtracted from 0, and 2 gets subtracted from 2. So we are having this matrices A minus B. So 0 minus 1 minus 1, 0. Next step, you have to multiply these two matrices A plus B and A minus B. This is a matrix A plus B, 2 minus 1, 1, 4. So right here. And the matrix A minus B is 0 minus 1 minus 1, 0. So right here. And then multiply these two matrices. Again, by multiplication rule, each row is multiplied with each column. First, the first row will multiply it with first column, then first row will get multiplied with second column. So in the resultant matrix, first row with first column, that is 2 into 0 plus minus 1 into minus 1. So we are getting the first element of the first row. Again, first row with the second column. You multiply and then the product will be added. That is 2 into minus 1 plus minus 1 into 0. We are getting the second element of the first row. When we are multiplying the first row with first column, we are getting the first element of the resultant matrix. First row with second column, we are getting the resultant second element of the first row. Okay, first row with each column. Now forget about the first row. Now come to the second row. Second row with first column and then second row with second column. The second row with first column will give the first element of the second row. Second row with second column will give the second element of the second row. So 2 into 0 plus minus 1 into minus 1, then 2 into minus 1 plus minus 1 into 0. So first row is completed. Now come to the second row. 1 into 0 plus 4 into minus 1. Okay. Then 1 into minus 1 plus 4 into 0. This is the second row. Now second row completed. So we are having this matrix 1 minus 2 minus 4 minus 1. Okay. Next, you have to find out the value of a square. So a will get multiplied with a. So write here a into a. Again, first row, first column, first row, second column will form the first row of the matrix A square. Then second row with first column and second row with second column will form the second row of the resultant matrix. That is 1 into 1 plus minus 1 into 0. This direction and this direction, okay? 1 into 1 plus minus 1 into 0. Then 1 into minus 1 plus minus 1 into 2. This is the second element. Now come to the second row. Second row with first column 0 into 1 plus 2 into 0. Okay. Now 0 into minus 1 plus 2 into 2. This is the last element. So a square is 1 minus 3, 0, 0, 4. Now find the value of b square. Write the matrix B into the matrix B. By multiplication rule, 1 into 1 plus 0 into 1, then 1 into 0 plus 0 into 2. We are getting the first row of the matrix B square. Now come to the second row. Multiply the element of second row with each column. First, with the first column, that is 1 into 1 plus 2 into 1. Okay. Next, 1 into 0 plus 2 into 2. This is the second element of the second row. Okay. So we are having this matrix B square 1, 0, 3, 4. Now by the property of matrix subtraction, a square minus b square. Here the value of a square 1 minus 304 right here. Then b square is 1034, so right here. Now subtract the corresponding element of this a square and b square. So 1 will get subtracted from 1. So we are having 0. 0 will be subtracted from minus 3. So minus 3 minus 0 is minus 3. 3 will be subtracted from 0. So 0 minus 3 is minus 3. 4 will subtracted from 4. So 4 minus 4 is 0. So the matrix A square minus B square is 0 minus 3 minus 3, 0. So this matrix A square minus B square is not equal to this matrix A plus B into A minus B. A plus B into A minus B matrix is 1 minus 2 minus 4 minus 1, which is totally different from this matrix A square minus B square. So we can easily write that A plus B into A minus B is not equal to A square minus B square. There are many more problems in this exercise, but we will discuss them later on after discussing some more concept related to this matrices. And the next lecture follows to the topic determinant, cofactors and minors. We'll discuss it in the next lecture. Thank you.